Okay, I will just open my can for a few seconds because I want to say hello for all of you from Brazil. Hey guys, I'm really happy to be here. It's bad that I'm not able to be there in person. I would love to be there to talk to you in person, but I'm pretty sure we are going to have this chance. We're going to have this opportunity next year, or maybe this year if you were going to attend any other conference that would be okay. So I hope I could talk to you. But I'm here and just want to say hello for you. I would just turn off my camera to avoid any internet glitch because I want you to pay attention on what I want to talk to you. So guys, what I have today is a session about artificial intelligence. Okay, so my idea is to give you a brief introduction about some terms related to artificial intelligence, talk about the beginning of artificial intelligence and what we have, and then I will try to spend the rest of our session, of our time, showing you a solution that I built using Azure Machine Learning Services. Okay, the solution is already done, and let me explain to you why it's already done. Because when you are building a solution using machine learning services on Azure, you need to process your model sometimes, and that could take a lot of time. And I want you to pay attention and see a solution that is working. So I already have, but I want to go step by step together with you guys, and I will explain everything that I did. And then if you have any questions, please just let me know. You can put them on the chat, and then I can help you with everything that is related to artificial intelligence and specific and Azure Machine Learning Services. So what is our agenda for today? Hey Peter, only 3 topics. Yeah guys, only 3 topics. I want to give you just a brief introduction about what is artificial intelligence, and then I want to talk about some of the technologies that you have inside the artificial intelligence area. For example, machine learning, that is what we are going to use here. Maybe you have some questions about that. So I want to talk about what are the technologies that we have, and then I want to show you a real model that I already developed, that I already created, and it's already working. So we can check it out and see how you can implement, how you can use artificial intelligence solution on in our daily lives. I'm pretty sure, guys, that all of you are already using artificial intelligence, and you start to think, hey Peter, no, I'm not using that. No, I'm not. I don't have a robot in my house. So guys, I'm pretty sure that you already are using artificial intelligence more than you know. Okay, so real quick, guys, I just want to give you my contact. So if you want to talk more about not only artificial intelligence, but if you want to talk more about SQL Server, if you want to talk more about Azure cloud computing, please don't hesitate to reach me. There you have my personal email. Okay, you have my blog is vitorfava.com. Sorry, it is a Portuguese blog. Okay, sorry for that because I'm from Brazil. But if you have any questions, you can send me in English. For sure, I can help you, right? And just don't hesitate to reach me if you want to talk about anything related to technology. Okay? I am a Microsoft MVP since 2016. So now I am a artificial intelligence and also a data platform MVP. So I can talk, and I really love to talk about database and AI and Azure stuff. So please just send me your questions. Okay? Awesome, guys. And can you see that on this picture? I'm really happy, and I'm pretty sure that I happy because it was pizza day here in my house. Okay, so every pizza day I'm always happy, right? I'm happy today because when I'm talking, while I'm talking to you, I'm already waiting for my pizza. Because here in Brazil, it's already 7, almost 8 p.m. So it's pizza time again. Okay, guys, so let's go. Tell me, let me ask you something. When you think about artificial intelligence, when you listen to someone talking about artificial intelligence, I'm pretty sure that this is what you are expecting, right? Don't be shy. I'm pretty sure that this is what you are expecting. When you start to read, start to study about artificial intelligence, when you have someone talking about artificial intelligence, this is what you are expecting, right? Yeah, I need to be honest. I'm expecting that too. But guys, this is what we have right now. Okay, this is what we have, and I'm kidding. I'm doing a joke just to let you know that we have a huge space for artificial intelligence solutions to grow. Okay, we are just starting to work, really to work on real solutions using artificial intelligence. Artificial intelligence, guys, it's something that is not new. Do you know that the idea, the theory about artificial intelligence started on 1956, 1955? Do you know that we already talk about artificial intelligence since that date? I'm pretty sure that not, right? So the idea about artificial intelligence, the idea to build, to code something, to build a mathematical model that simulates a human being taking a decision, it's not new. It's not new at all. And you can ask to me, hey, Peter, so if it's not new, if it's so old like that, because it's really old, right? It's really old. Why just now, just start on 2014, we start to have some AI solutions? Answer me that, okay? Yeah, I will. Oh, for sure I will. And there are some reasons for that. So let's go. The idea about artificial intelligence, it's not new, but to build a real artificial intelligence solution, we have 3 pillars. Okay, we have 3 pillars. We need data, we need processor power, and we need data models. Tell me something, guys. In 1956, do you believe that we had so much data like we have today? Of course not, right? Today we have this beautiful word, this awesome concept called big data. What is the idea about big data, guys? Big data. Hey, Vitor, big data. A lot of data. A huge amount of information. Yeah. Today we are producing data every second. Every second of our day we are creating some new data, guys. I'm pretty sure that some of you are watching this session on your computer, okay? But I'm pretty sure that some of you maybe are using your smartphone connect on the internet, or your tablet, or even your PlayStation 4, your Xbox. You're watching that using a different device. So right now, guys, we are producing so much data, and this is awesome if you want to work with artificial intelligence. Why? Why, Peter? Why this is so important? Remember, the idea about artificial intelligence, the main idea about artificial intelligence is to build machine. And guys, I'm talking about a machine, you can just imagine a solution, right? Doesn't matter if it's a physical machine or just a code, but let's imagine a black box that it's intelligent to take a decision. Okay, so if you want to build a machine, if you want to build a code, and then ask for that machine to take a decision like a human being, what do you need, guys? Let me ask you something, and then you can give me the answer. How do you learn something new? How do you learn, for example, a new feature on SQL Server? You read, you study, and you practice, and then you become an expert, right? So you invest maybe 5 years, 6 years, 10 years of your life working with SQL Server, learning every day, and then now you have a lot of experience, guys. So to take a good decision about a SQL Server issue, for example, you have experience about SQL Server. If you are a doctor and you need to take a decision about a patient, what do you need? You need to have experience about that area, okay? I work with brains, so you need to have experience, right, to take the best decision. So we spend time to gain experience, but we cannot wait for a machine. For example, you cannot start to code something today and then wait for 20 years, 10 years for that machine to become smart. What do you need? You need to give data for this machine to simulate experience, right? So if you show a lot of data, a lot of examples to a machine, that machine can analyze that data and discover some patterns, identify some patterns there. And this is what we are going to do today. Okay, I'm going to build something that will analyze a data set and predict something to us. So the first thing that we need is data. And now we have data. Man, we have so much data that sometimes this is a problem, okay? Because to build something related to artificial intelligence, we need data, but we need good data. We need to have some quality on our data, okay? So this is the work for a data engineer, to manipulate that data, to do some cleanup, to process something and give that data to us. The second thing that we need, and it's really important, if you have a lot of data and you need to process that data, what do you need, guys? You need processing power. Okay, you need a huge machine. You need a huge server. And again, if we start to think, when you were in 1956, you don't have a lot of processor power, right? You don't have a lot of processor power, but now you have. What about cloud computing, guys? What about if you need to create a new machine, if you need to ask for processor power, you just need to go to your cloud provider. Could be Azure. In our case here, it's Azure, but could be AWS, could be Google. You just need to go there, create a new virtual machine, add a lot of memory, add a lot of cores, and then you have a huge machine with a lot of processor power to process your data. Awesome. And then we have our third pillar, that are the data models that we have. The data models that we have that we need to implement our analysis. Okay. And now we have everything. So now I can create something real. I can create a solution for you. I can create something that you can show to your client, that you can use on your daily basis, right? And let's talk about some of the technologies that you have inside artificial intelligence area, and the one that we are going to use on our session today. That is machine learning. Okay, so machine learning, it's below artificial intelligence. So the idea of machine learning, right? It's related to use data to train an algorithm, and that algorithm based on some rules will predict something to us. Okay, will predict something to us. For example, guys, how much of you like to watch TV shows on Netflix? I'm pretty sure that most of you are watching TV shows on Netflix, right? And when you finish to watch a show and you go back to your main screen on Netflix, you have something like, hey, you watched this series, and I'm pretty sure that you are going to like those shows here. So Netflix is suggesting something for you. It's recommending something for you, right? It's an artificial intelligence solution. Whoa, Vitor, really? This is an artificial intelligence solution? Yes, guys, this is an artificial intelligence solution. Okay? You can imagine how much data Netflix has. Man, I don't know. I don't have idea how millions people you have watching Netflix at the same time. Okay, I don't have any idea, but you can imagine now at this moment with coronavirus and everything, and start to think most of the time when you have like a Netflix recommendation, it's a good recommendation. Yeah, it's a good recommendation. Not 100% of the time, but most of the time you have a good recommendation. Okay, right? Like another example, like Amazon, when you are buying something, you have like a recommendation. Hey, you are buying this book, and most of the people that just bought this book, they were really interested on those other two. And most of the time, it's relevant for you. Okay, this is also an artificial intelligence solution working. Okay, guys, machine learning, in my opinion, is the main driver of artificial intelligence. It's because of machine learning that you have so much hype on artificial intelligence right now. Machine learning is just a small portion of the huge artificial intelligence area, but I believe it is the topic where you have more solutions running, and of course it's a machine learning solution that we are going to build today. Okay, so when we talk about machine learning, it's important for you to understand and to have those terms in your brain and your head. Okay, we have two types of learning when we are working with machine learning. We have supervised and unsupervised. Okay, here on my session today, guys, I want to show you a supervised learning solution. You can see that on the supervised learning solution side, there are classification and regression. And what I'm going to use today with you guys, it's a classification scenario. Okay, it's a classification scenario. What is the difference between a supervised learning and an unsupervised learning? The difference is related to the data set that you are going to use to train your algorithm, to train your machine learning. If you are using a data set where you already have the information you want to predict, it's a supervised learning. Okay? Hey, Peter, I did not understand what you tried to say. Let me show to you, guys. Let me show to you what I'm trying to say. I will just open the data set that we are going to use on our solution. That is this one. Let me show you. I will just put here so you can take a look. So this is the data set. Let me just do that for you so you can take a look. Guys, this is the data set that I'm going to use to build our machine learning solution. Okay. I'm going to do is to build a model that is intelligent enough to predict if a patient has or has not have not diabetics. Okay, this is what we are going to do. We are going to predict if a patient has diabetes or not. Okay, take a look here, guys, with me. On my data set, and this is the data set that I'm going to use to train my machine learning and to test my machine learning. I'm talking about that in a few minutes. Okay, so here I have some columns about the patient. So I have the patient ID. I have if the patient is pregnant. Okay, I know that I have not pregnant. Okay, 1 month, 9 months, 7 months of pregnancy. Okay, I have, for example, information about blood exam, about blood pressure, about BMI, right? So those informations we call features. Those features are the details about the subject that I want to do an analysis. Okay, and why this is a supervised learning? Because guys, this is a patient. I have all the information about that patient, and I already have the column that I want to predict. See, this patient is not a diabetic one. This one is a diabetic one. This one too, but this one is not diabetic. It's not diabetic. Okay. So I'm going to use this data set to train my model. And then after I train my model with that data, if I show new data, my machine learning model is able to predict, okay, using that information, those features, I believe that this patient has diabetes. Okay. And why this is a classification model? Because of the results of my prediction. See, it's a categorical information, right? It's 0, 1. It's 0 or 1. It's a categorical information. Okay? This is why it's a classification. I'm just identifying and creating a categorical output. For example, if we decided to work on the regression, the idea of the regression is almost the same. I have the data set and I already have the data that I want to predict, but the output of the regression model is not a categorical information, right? For example, if you want to predict the price of houses on a specific area of your city, you have some data about houses that you want to analyze, and the price of a house is not a categorical value, right? It's not a categorical value. It's a continuous value. Okay? So this is the difference between a classification one and a regression one. And on our solution, guys, we are going to build a classification one. Okay? Okay, guys, so this is what I have to talk to you now. I don't want to talk anymore on these slides. That's enough talk. Let's go to the demo, right? Let me show you how this is going to work. So let's do it, guys. I will just open my Azure portal. So let me connect on my Azure portal. Okay, let's do it. I'm always excited to talk about artificial intelligence and machine learning, guys. It's so cool. It's so amazing. You're going to see this working right now. So, guys, uh, the first thing that we need to do, I already did that because I want to show you everything working. I don't want to spend your time building something or just allocating the resources on Azure, but I already created. See, I already created our workspace. So the first thing that we need to do is create a machine learning workspace. I already have that. Let me show to you. I have some of them. Okay, I have some of them here, and this is the one that I'm going to use. Right? Uh, let's take a look here. So guys, here it's where you start to implement your machine learning models, okay? The only thing that I want to show to you right now on the workspace, it's related to this item. Hey, Peter, but there's so much thing there, experiments, pipelines, model. Yes, guys, we have a lot of things here, but I don't have time to talk about all of them. I want to show you a solution. And the thing that I want you to pay attention is this one, compute. Remember that I told you one of the three pillars, we have big data and we have processor power. So here it's where I'm allocating the processor power that I need to process and to train my model. Okay, I already have, if you take a look here, I already have a computer. See, I already have one. And I just want to show to you that if you want to have more processor power, you just need to come here and select a computer name. Let me just show to you this one that I want to show you. You can choose if you want to use a CPU or a GPU processing unit. If you are working with uh, image processing or something related to that, for sure you need some GPU, right? And here, oh, here guys, here you can take a look and select how much cores do you want to use, okay? What is the amount of RAM memory that you want to use to compute your model, okay? Okay, guys, so I already have one. I already created because I don't want to spend time that. I will just leave. I already have one. And let me show you the studio. So I'm going to access the Azure Machine Learning Studio, where I'm going to build my model without code. Okay. Hey, Vir, so I don't need to know how to be a developer to work with machine learning. No, you don't need that. Okay. For sure that if you know how to program and if you want like an advice, uh, if you want to know the best language or at least the most used language right now in machine learning universe is Python, right? It's Python. Okay, so if you want to start to learn a new programming language, just go with Python. Okay, so guys, I already have here. Let me show to you. I have my experiments here. I will show to you this one. It's already done. And let's go through our model so you can take a look and understand what I'm doing. The first thing that we need to do is to load our data set, right? The data that we are going to analyze. Remember that here we are training our machine learning. So this is my data set, the data set that I'm going to use to train my machine learning. Okay, it's the same data set that I just show it to you. It's this one, but one thing that is really cool, guys, when you are using Machine Learning Studio, you can just do that. You can just right click here. You can go in data set and you can go and visualize. and you have some great details about your data. See here, guys, you can take a look on how your data is distributed. This is a good one, right? This is a good one. You can see that we almost have like a bell shape here. When you have a bell shape here, we use a term called normalized data. So we have a good distribution of data. It's different from this one. See, we have a huge spike here. This could be an outlier or not. So we need to take a look. We need to remember that I told you it's not enough to have a lot of data. You need to have a lot of data, but you need to have quality on your data. Your data needs to be good for you to analyze, right? Here you can see that, okay, we have a good distribution. Here we are okay too, but there are some columns, for example, here, when you have a huge spike like this one and this one. See? So the first thing that we need to do is start to do some transformation on our data and bring everything close to the same range. For example, you can see here that on pregnancy we have like small numbers, okay, and here on plasma glucose the numbers are higher, and here you already have a different range, and if you take a look here you already have another range, and on diabetes pedigree you have another range. See, so the first thing that we need to do is to start to work on some transformation and try to bring everything to the same range. Okay, this is what I'm doing here. I'm using some data, some tasks, and the tasks, they are here on the left side. You have here a panel where you can just take a look on your tasks. And what I'm doing here is start to work on some operations that we call normalization, right? So the first thing that I'm doing, let me show to you, is working with the age column. So I'm working on age column, and I'm using a math function here, trying to adjust the age on the same range of the data that I want to work. Okay. After I execute that, let me show to you. I can just go here and visualize the information. Let me show to you. I have here, guys, our original age. This is our original age. See, so I have 21, 23, 23, 43, and after I use that function, take a look on the range. The range is totally different, okay? And also take a look on the distribution. This is the histogram after I just process that information, and this is the histogram when we started to work. It's a little bit different, right? Okay. Hey, here, but you still have a huge spike here. Yes, I have, but if you take a look here, the data is almost on the same interval, right? 3.0, 4.3, this is almost okay, right? Different from that one. See, I have a 21 and I have 77, okay? And what I'm doing after that, it's the same idea, but using different functions on different columns. Here I'm doing some normalization using a z-score function. And after that, I'm using another normalized task using a min-max function, okay? And after that, this is what we have. Let me show you guys, and then you you are going to understand what I'm trying to say. Man, this is so cool. This is so cool. This is so amazing. Guys, take a look here. Remember when I started to work and I just loaded my data and I explained to you and show you the range of my data. Take a look now on my columns, and you see that all the columns are almost in the same range. See, 0, 0.5, 0.2, 1.9, 1.2. Take a look. All my columns now are on the same range. See here, all my columns are on the same range. So right now, I have the data to train my machine learning algorithm. Okay, let me just do that. Okay, guys. Okay, let's talk about everything I did until now. I just loaded my data that I want to analyze and train my machine learning model, but that data is not ready yet. It was not ready when I started to work because I had difference between the features. Remember, the features are the columns. They were using different names. So I just started to do some normalizing, and now I have everything in same range. Now I can use this data set to train my machine learning model. Okay, so when you train your machine learning, the first thing that you need to do is to split your data. What I want to say, hey Peter, what do you want to say splitting your data? Okay, guys, the data set that I have, the data set that I worked until now, it is the data set that I'm going to train my machine learning. But after I train my machine learning, I would like to test. Okay, I would like to test if that machine learning is working. So to test, I need some test data. Okay, so what I'm going to do is to split my original data set, and I'm going to use 70% of that data as examples to train my machine learning model, and 30% to test if my machine learning is working fine. Okay, so this is what I'm doing here on this split data test. If you take a look, I will show it to you here, guys. I'm just saying, okay, I want to use 70% and 30%. And then I have two outputs, right? Two outputs. One output to train my model, and the second one to evaluate my model, right? So the first one I'm going to use to train, and the second one I'm going to use to evaluate. To train my model, guys, I'm using a task called train model. Okay, and here I'm using two classification models. I'm using this one that is a two-class logistic regression, and this one that is a two-class boosted decision tree, right? Just to show you the difference between them. Why, Victor, are you using two? Guys, because how do you know what is the best algorithm to use to predict something? How do you know if the logistic regression is better or if the decision tree is better? I don't know. I need to test. I need to test. I need to test. So you train your model and test. and then you analyze the metrics about your prediction. So if your prediction is not good enough, you just go back to your project, select another algorithm, train again, test again, and take a look if the prediction is good, if the prediction is working fine. So this is the way that we need to work. And you would be thinking, hey, Vitor, but this is a lot of work, right? Is there any other way to test or to automate these tests and then after that have the best solution? Yes, there is something called auto machine learning, auto ML. This is not the topic about our session, but it's really cool. And if you want to talk to me about that, if you want to discuss about that, man, just send me an email and we can talk about that. I have some good clients here in Brazil working with that. I have some clients outside Brazil, US and Canada working with that. So if you have a project and if you want my help, let's talk about that. Okay? So cool. Here I have my trained data, and then I'm going to analyze that. So take a look. Take a look, guys. Here I have my model. I already trained my model, and here I have a test, right? See, this output is a test, and then I can just analyze and take a look here. Let me show to you. Guys, this is our results. Here is the original column. Remember? The column with the original information. So this is the information about the patient. And this one, this scored labels, is the column related to the prediction. Okay? This is the prediction made by our model. And you can take a look. Hey, this guy has diabetes, and my model will say, yeah, this guy has diabetes. But guys, we have some errors. Yes, we have some errors for sure. For example, here, this patient has diabetes, but our model just predicted that not this patient has not diabetes. Hey, Vitor, so this is bad, right? Yeah, this is not good, but again, it's expected. First, because we do not have a lot of data. We don't have so much data, so we do not have a lot of examples. And again, it's not 100% accurate, right? It's not 100% accurate. You could be some errors. This is an example, okay? This is an example, right? But guys, we can evaluate our model. Take a look here. I can see on this evaluation task about my predictions and how it's working. Okay, here I just one example. Okay, guys, you have a lot of metrics, a lot of performance metrics to see if your algorithm is working. I have this graph here. I have these two lines, see, and one of them is close to one, and the other one is really far for one. Okay, so this one here is a good one, because if you are close to one, your prediction is good. If you are really far from one, your prediction is not good at all, right? So on our example, remember that I'm testing two different algorithms, right? So this one here is the best one. This one here is the one on the blue line, on the red line. Sorry, let me show to you here. Hey, yeah.
We have a question. What is a class
Sure.
logistic regression and class boost?
Oh, sorry. Can you repeat?
What is a class logistic regression and class boost? I'm guessing the task.
Let me. Yeah, the question's about those two tasks here. Okay.
Yeah, what
Okay,
are
guys.
those?
Let me show it to you. That is it's an awesome question. Thank for that. Remember that I told you about analyze the data and predict something, right? Those two are algorithms that you can use, mathematical algorithms that you can use to predict something, right? Let me show you something, guys, and this is better for you to understand. I have here machine learning, and let me show to you now what I want to show you. Not here, not here. And then I believe that will be better. Let me just put here two class here. This is what I want to show you here. Remember, guys, that I told you machine learning about classification and regression. So to work on a classification analysis, you have different mathematical algorithms to use and to do some analysis, right? Those are all the algorithms that you can use. See, there are mathematical possibilities to analyze your data and give you an output, give you a function to create a prediction. Okay, those two that I'm using here, they are related to a classification analysis. Remember, a classification analysis is that analysis that you have a categorical information. It's 0, 1, it's true or false, or something like that. So all of those I can use to do a prediction based on a classification model, right? Okay, I believe this was the question. If I was not able to answer your question, please do it again. Okay. Just to compliment. Hey Vitor, why did you choose that and that one? Just for a test, just to show you. I could just select that one here or that one here. Okay, and this is what I was talking to you. That is a test. You need to implement, you need to test, you need to analyze the results, and maybe if none of those were good enough, you just need to select another one. Okay, here it's where automated machine learning it's working, because an auto ML solution is going to test all of those and give you the best one. Okay, this is cool, right? You have a machine learning training another machine learning to select the best algorithm to use. Yeah, this is awesome. It's a machine learning training another machine learning. Okay, awesome. Please, if you have any other question, just ask me.
Yes, John is saying again, how can we learn about this and know which one to use?
Oh, that's a good question. I love it. That so take a look. If you just click on the task here on the left, on the right panel, you have the properties about them, and you have here, see, a quick help. And when you just click here, you are redirected to the Microsoft documentation, and then you have here the information about this algorithm, and then you have everything that you need. See, you have all the information that you need to work with that. And I use that a lot, guys, because I don't know, I don't remember all of them, right? I don't remember all of them. I just go to the documentation and see an example and see the notes here, and then I go back to my experiment and try one of them. Okay, all of them, right? everyone, if you click, you have here help, and then you can just click and you are redirected to Microsoft documentation about that task. Okay, cool, awesome, awesome. Okay, so after that, guys, I still have a few minutes, and then I will have time to show you that working. What we need to do is to create a web service. Okay, so this is my model, and I already finished everything. I already tested, I already trained my machine learning model, and I already have a good prediction. I'm happy with that, so I want to use that. So you create a web service here. I already did that for you guys because I want to show you working. And I have here my web service. Let me go here, and then you are going to see my web service management, and I have my web service here. Okay, see guys, I already have my diabetes predictor here. So I just need to use that. I will show you an example how you can use that. I'm going to use an Excel file. Let me just download this one. It's easier, then we have enough time for do that. So here I have my Excel file. Let me open that. I already have my adding to connect on Azure Machine Learning here. I already used my credentials, okay? I already connected on my portal. So here's my web service. I'm going to use that one. And I'm going to use some sample data. Let me just do that. See, guys, I have some sample here. And what I'm going to do is send this information to my model. My model is going to analyze all the features, and using everything that the model learned, the model tested, we are going to have a prediction. If, for example, this is a patient with diabetes or not. Okay, so let's do that. I'm going to use a sample data, and yes, this is my sample data here. And my output is going to be on J1. I'm going to output my results here. I will just predict, and here we go, guys. Take a look here. Let me just close this one. I don't need that anymore because I already have here. Take a look, guys. Here I have our prediction. So this patient, the probability is that this patient is a diabetic one. This one not, and this one it's a diabetic one. And here you have the probability. 0.9 is good, 0.9 is good. See, now we have a model working. This is a real case scenario that you can build. It's a classification, right? It's a classification because we are predicting just a categorical output. But man, take a look, guys. We just built a real machine learning solution. Okay, awesome, right? Awesome. I know there are a lot of information. I'm pretty sure that maybe you will start to think, man, I have so many things to learn. And yes, you have, but guys, you can do it, right? You can do it, and I'm here to help you. Okay. I just want to give you last advice, guys, and say to you that first, thank you for everyone that is watching my session. Thank you, guys, and thank you for the organizers to give me the chance to show you some of what I'm doing with machine learning and Azure and SQL Server for sure. And I would like to say to you that you are the master of your career. If you want to start to work with artificial intelligence, you can do it. It doesn't matter if you are 40, 50 years old, 30 years old, doesn't matter at all. If you want to learn something new, just go and get it. Just go and study about that topic and you are going to learn. Okay? Guys, I really want to say again, and if you need anything, just reach me. Let me just put here my contacts again. Don't hesitate to send me an email, please. I'll be more than happy to talk to you about everything I demonstrate, or if you need something else, or if you want to work with something else. Thank you, guys.
Vitor?
Yeah.
So we have two questions. One raised hand from
Okay.
Deepa. Let me unmute Deepa.
Mm-hmm.
Deepa, you're unmuted. You have to unmute yourself to speak. There you go. Oof. Deepa? Or okay, so maybe she raised the hand by error.
Hi.
Hi. You have a question?
No more questions.
Oh, okay. Okay.
Sorry.
So let's go to the other question from Milton. He say hi and he asks how you can analyze a good accuracy score of result set.
Okay. Let me just go back on my Azure portal. Yeah, that's a good question. I will just show that real quick. And remember that on our solution, I have this test here, the evaluate one, right? So this test evaluate model is the test that you are going to use to analyze if your prediction is accurate enough. If you just go here and select visualize, let me show you. That's a good question, right? And just to give you an information, guys, if you are working with a classification model, you have some metrics to use to analyze your accuracy. And if you are working with regression, you have a totally different metrics to use, right? So the first one that you can use is this graph here. Remember that I told you if you are close enough to 1 is a good prediction, right? If you are far from the 1, it's not a good one. But you can also use here a confusion matrix to take a look, right? Here, if you take a look, my prediction, my precision, see, it's not good enough, 0.7. If I select the red one, I will just show you, it's totally different. See, it's a 0.9. So my accuracy is 0.951. So this one is a good one. So here you can use the confusion matrix also. But for example, if you are working with regression, you have different metrics to use. So it depends what is first, if you are using a classification or a regression. And if you're using a classification, you can use a confusion matrix. If you're using a regression, you have different metrics to analyze your accuracy. Okay.
Okay, we have more questions. So this
Awesome.
is the last session. So if you don't mind, we can keep answering if you don't mind. So
no, that's okay for me.
Okay, Alpa is asking, is there any way we can do unit testing automatically using any auto testing software tool?
Let me see if I understand the question. When you say unit test, you would like to automate this process here. If this is the case, as I was talking to you guys, we have automated machine learning. That is another service that you can use on Azure, and you can automate your training. You don't need to select an algorithm. You have a service that is going to analyze your data, and you can choose, for example, I want to do a classification analysis, and after that you have an automation process running that is going to use a lot of examples, a lot of algorithms, and then select the best one for you. I believe this was the case. If not, please do it again, your question.
Okay, and then John is asking, how can he train on this? I'm guessing he's looking for more resources to learn.
Oh, do you want to know more about machine learning at all in general? If yes, oh, you have so much material, man. Let me just, the first thing that you have, and I can tell you that it's Microsoft documentation. Okay, here. I was just showing you guys some topics about a specific task, but if you want to learn more, you can use the machine learning reference on Microsoft documentation. The first thing that you can do, you have a lot of great material on Coursera. I believe we have some time. Let me show you a quick one, and this is I believe the most famous training about machine learning, and it's for free. Okay, it's for Android, and it's on Coursera, right? This one, I believe everyone is able to see my screen. Let me go here. Is this one, guys? Just go on Coursera and search for machine learning. It's for free. This course is totally free. It's one of the most amazing training that I already did. It's not so easy. You need to invest some time of your day to study, but it's a great training about machine learning. Okay, specific about machine learning. Remember that artificial intelligence is not only machine learning. You have deep learning, you have natural language process, you have a lot of things happening inside machine learning, inside artificial intelligence, sorry, and machine learning is just one of, it's a piece of artificial intelligence, but that training is one of the best that I already made.
Perfect. No more questions.
Oh, okay. That's okay.
Okay.
Guys, if you have any questions, just let me know. Don't be shy. Okay, don't be shy. I really love to get emails from you guys and help you to learn more about that.
Perfect.